What if we have to?
Okay, so 1-8, this is the final section in our notes before we do our test next week. So this is called constant, which we've been talking about, the constant rate of change. This section ties everything together that we've learned with our proportions and our charts and our graphs. So this is the constant rate of change. So we're going to define a couple things first. The first thing I want you to write down is rate of change. And this is a rate that describes how one quantity changes in relation to another. A rate that describes how one quantity changes in relation to another. The other definition is constant rate of change. And when it says constant, that just means that it's linear. It's all this stuff here, but now it's linear. What does linear mean? What do you think? Someone raise your hand and tell me. What does linear mean? Zach?
Small.
Not small. What word do you see in this word right here? Josh?
Line?
Good. I see line. So what do you think linear means?
It's a straight line.
Yes. And remember when we looked at the graphs and we said, oh, it's a straight line. And to be proportional and constant, remember it had to go through the origin, 0, 0. So this is linear, just means a straight line, okay? It doesn't bounce all over the place. So if you want to put a line there to remind you, it's linear, straight line, okay? So we've been looking at charts, and there's a bunch of charts and tables and graphs and things like that in your book. But I want to do one of them in the notebook as well, so you can use this on quizzes and tests and stuff. So let's write example 1. And we're just going to draw a quick little chart here, little table. Okay, so this is going to be a chart, and it says cars washed. So we're going to talk about a car wash for like a fundraiser. And we'll have the number of cars here, and then we'll have the money over here. So it's like basically 2 columns, number of cars, and money. Okay? So for 5 cars, they collect $40. For 10 cars, they collect $80. 15 cars is $120. And 20 cars is $160. And that finishes off our chart. So let's look at the left side. This one is going up by how much?
5.
5. So put a plus 5. It's going up, plus 5. You get it, right? Plus 5. How about the right side? How is that changing? It's going up by 40. Each one goes up by 40. Okay? So if we want to find the unit rate, so over here, right, unit rate, remember unit rate is over 1. This would be $40, not over 1, over 5 cars, right?
Yes.
Which equals what?
8 over 1.
8 over 1. So the unit rate is $8 per car. Okay? Is this linear if we graph this? Would it make a straight line?
Yes.
Yes. Would it be proportional?
Yes.
Yes. Because at 0 cars, they would make $0. So it would have to go through the origin. Okay? So that's a real basic chart. And then we're going to do one with a graph, just to have 2 examples here. And then we're done with notes. Okay, so example 2. I'm just going to sketch out a quick graph. And we're going to say that the bottom, the x, right, this is the x, will be time. And the y will be distance. And we'll say the distance is in miles. Distance in miles. And time we'll put in hours. It's easier that way. Okay, so let's say that I'm driving down the road, like I'm driving to, where should I go? I'll go to Walmart. And so I'm driving, and let's say we'll go in minutes, oh sorry, we're going in hours. So we're going to go 10th, so put 0.1, 0.2, 0.3, 0.4. We're going to make these small because we're using hours. What's a tenth of an hour? Anyone know? How many minutes are an hour? 60. So what's a tenth of that? 6. So this represents 6 minutes, 12 minutes. Do you get it? Each one is going up. So we're just going to go to 0.5. Okay? So at 0.5, what is this? It's half of an hour. So that's 30 minutes, okay? And then we have distance. So we're going to do over here, we're going to do 1 mile, 2 miles, 3 miles, 4, 5. Okay? So I'm going to start at my house, which means I haven't left yet and I haven't gone anywhere. So that's right here. Put a dot. That's 0, 0. After 6 minutes, I've gone a mile. After 12 minutes, which is 0.2, I've gone 2 miles. After 18 minutes, I've gone 3 miles. After 24 minutes, I've gone 4 miles. And after 30 minutes, I've gone 5 miles. Okay, so I'm just driving along. These are my minutes and these are my miles, okay? I drive slow. Here we go. So it could keep going, right? But let's just say I stop right here. Is this linear?
Yes.
Yes. Is this constant?
Yes.
Is this proportional? Yes. Does it go through the origin? Yes. Okay, so we already know that. We know that. But what's the constant rate of change? Do we know that?
No.
No. So how do we find it? Anyone know? What? I can tell you this. To get the constant, right? The constant, so write constant right here. I need the change in miles. Over, or divided by, the change in hours. Okay, to get the constant, I need to get the change in miles divided by the change in hours. So the change in miles is just 5 to 0, right? 5 to 0. So we're going to put 5 minus 0. That's how we get the difference. Think change is like a difference. And I'm going to write miles so you guys remember it's miles. How do I get the change in hours? Where did I stop? 0.5 minus 0. And this is hours. Now I have 5 over 0.5. Does that look like a unit rate yet? No. I want a 1 on the bottom, right? So I take in my calculator 5, some of you already know this in your head, divided by 0.5, and that gives me, does anyone know? 10. Is that what you're going to say? 10 over 1. 10 over 1. So this is 10 miles per hour. Okay? So this right here is the constant. It's also a unit rate. Did you notice here with this one, we had a constant that also had a 1?
Yeah.
Okay? So we're going to be looking for that. So just remember, it's the change in miles. Did you notice that was the y?
Yeah.
So I want you to write over here the y over the what? X. Now this right here, this y over x, this change in y over this change in x, this is going to come up for the next at least 5 years in math, this formula. This is it real simplified, but it's going to get more challenging. But just if you can remember, you get this constant rate by dividing the change in y by the change in x. If you flip-flop these around and you did hours over miles, it will be wrong. You need to have y and then x. Okay? So this is going to just keep coming up for a long time in math. We call it other things as we move on. But just for Math 7, we're just going to go with that. Any questions?
Nope.
Got this? We're going to try. We're going to do some practice now.